Hello, my name is Pedro-Lopez, and this is my presentation for the pseudocode for EEL 2161 project. For the first choice, which is choice B, the requirements for it is that we have to have a multiplication of two matrices where the user is required to prompt how many rows and columns each matrix will have for A and B. The second requirement is that if the column number A of set A is not equal to the row number of set B, the user should be prompted to check the dimension and to retype it. If the dimensions are satisfied, we will perform the multiplication of two matrices of A and B and return the result back to the user. To begin the code for choice B, we will have to start with header files, in which we would just include a studio.h, and then after that we would start the main body of the code, and we will begin by stating four variables, which are row A, column A for matrix A, row B and column B for matrix B, and they'll all be defined as an integer function. Afterwards, we will use the print function and the scan function to ask the user to input the number of columns and rows for each matrices, and we will have them return the value to column A, row A, column B, row B. After we get the number of rows and columns, we will input row A and column A, and it will be used for the array called matrix A and will be defined as a float function, and same will be for column B, row B, and it will be implemented in the array called matrix B. Once matrices are defined as float with the numbers desired by the user of rows and columns, we will use if statements to determine if the multiplication of matrices is possible. To start the if function, we have to use a condition of if column A is equal to row B, then we can continue with the following. We will state variables I and J as integers, and those will be used for the for loops in the if statements. We will start with the first for loop where I starts at 0 and I is less than row A of matrix A, and I will be added by 1 each time it's implemented. We will repeat this for integer J, which will be inside the brackets of the for loop for I, and have everything the same except that J will be less than column A for matrix A. In order to receive and give back the users the values of the matrix A, we have to use the printf and scanf function, and whenever we will ask for the first matrix row 1 column 1, we will have to have I plus 1 and J plus 1 at the end of the print function due to the fact that we started I at 0. We will repeat this in order to get the values for matrix B. Once the user has given us the values for both matrices, we will have to return the values to the user's terminal by using two float functions, one for I and for J, just as before, but instead we will have just a printf function where we will give the values of both matrices, with matrix A and matrix B being at the end of the printf function. To begin multiplying the matrices, we will have to create a new float array with the values of row B and column A. We will have to state a new variable K, which will be an integer function, and we will create 3 for loops for I, J, and K. I will be the beginning, J will be inside of for loop I, and K will be inside for loop J. All of them will begin at 0, and they will all be less than the column A in each condition, and they will all be added up by 1. We will set the new float array to 0 before the for loop for K. In the brackets for loop for K, I will have to write an equation that will add up all of the float array for matrix A for I and K, and matrix B for K and J, since column A is equal to row B, which will be set equal to K at the end. Once all the values are stored within the for loops, we have to display the new array using another for loop that would show it on the user's terminal. We would use it the same way as we did before with I, J, and we just print out the result of the multiplication. And then towards the end of the if statement, we have to clean it up and go back to use /n to space out the printf functions and have the line, the absolute value line, to divide all the matrices up to make it all look organized. If column A does not equal column B, we will use an else statement, and within the else statement, we will have to display a message to inform the user of the error. And I am thinking of using a do while loop, and we'll have to do while loop set have the beginning first two printf and scanf function, and have the while loop repeat it if the entry of row A does not equal column B, and we will end the coding by returning to 0, and that's it for choice B. To start off for choice D, we will have to look at the requirements given to us. The first requirement is we will have to be finding the solution of a simultaneous linear line with 3 unknown variables, which will be x, y, and z. The user will be prompted to type in the elements for both matrices A and B, and the script should be used to the script will be used to find the answers by using the Craner's rule and show the result to the user's terminal. We are required to find the determinants for the Craner's rule by using the user-defined function that will return a value and takes multi-dimensional array as arguments. We will start the coding for choice D by including the header studio.h and also having the defined function that we name determinant in the header. Then we will start the main body of the code, and we will start by stating the same 4 variables we did as choice B, which is row A, column A, row B, column B. And since the user was not asked to input the number of rows and columns, we will assume that we can use the example display. And in the example display, we had where row A is equal to 3, column A is equal to 3, row B is equal to 1, and column B is equal to 3. We will state matrices A and B as float functions, and then we will have them have array numbers of row A, row B, column B. We will then introduce variables I and J as integer functions, and we will create 2 for loops. The first for loop will start with I equaling at 0 and I being less than row A, and it will be added up each time it's implemented. And within that for loop, there will be another for loop for integer J, where it will equal out to 0 once again, and it will be less than the number of column A. Within the bracket of the second for loop, we will have to use the printf function, which will ask the user to input the values of matrix A, and we will have a scanf function with the AND matrix I and J used in it in order to receive the values for the first matrix. And then we will repeat the same steps in order to retrieve the values for matrix B. We would then display the values of both matrices of A and B to the user terminal by using 2 for loops again as before, but instead we would just use one printf function that will display the float numbers of matrix A, of I and J, the same for matrix B, and it will be shown to the user by the terminal. We will have to leave some space between that and then the return 0, because we will come back and return a function into the main function. We will start a new code body, and that will define the function of the determinant, which will have the values of matrix A and matrix B of I and J for both. Within the new user-defined function that we titled determinant, we will have to use the float values of matrix A and B as the inputs of the function. I would use the equation that we were given from the link provided in the assignment for the matrix of 3 by 3 of matrix A, and we will have to input the values needed for the results. Once we have that, we will close it by having it return as determinant into the main function, and then insert it into the space where we left for this part of the code. We will use the Kramer's equation and insert it into the code after the user-defined function in order to find the variables of x, y, and z. And in order to print out the results to the user, we will again use two for loops, I and j, with each of them less than the respective value that we will be using. And then towards the end, I will be using the /n in the printf function to separate all the code lines in the user terminal, and then use the absolute line to help organize the matrices throughout the code. And hopefully this works, because it seems to work at some aspect.